What is continental drift? It's a hypothesis proposed by Alfred Wegener that all of today's continents were once part of a single landmass. Wegener called this single landmass Pangea and proposed that it broke into pieces and drifted to the continent's present locations. Alexander Detoit suggested that Pangea first separated into Laurasia and Gondwana. Wegener developed his hypothesis by looking at the shapes of the continent's climatic evidence, rocks, fossils, and land features. As map making advanced, maps began to show more accurate shapes of the continents. The matching coastlines support continental drift because they suggest that the continents were once connected. Fossils of the same plant and animal species are found on continents separated by vast oceans. Scientists inferred the continents were joined when these plants and animals were alive. Different continents also have matching rock layers and land features. Locations of coal deposits and past glacial activity provide climatic evidence for continental drift. Coal deposits found in cooler climates suggest that these continents were once closer to the equator. The past movement of glaciers across South America, India, Africa, and Australia only made sense if the continents were connected when the glaciers existed. At first, continental drift was not widely accepted by the scientific community, but the hypothesis evolved into the theory of plate tectonics. The plate tectonics states that Earth's surface is made up of giant moving slabs called tectonic plates. The theory requires a great deal of evidence and is a system of ideas that explains many related observations about the natural world. The theory of plate tectonics explains how moving plates shape land features and how the motion relates to Earth processes. During seafloor spreading, new seafloor forms and pushes existing rock into opposite directions. The far edges of the spreading seafloor are pushed into the deep ocean trenches through subduction and the process by which one plate is pulled beneath another plate. What evidence supports this? The North and South poles have repeatedly switched throughout the Earth's history, resulting in a magnetic reversal. As new seafloor forms, magnetic minerals align with the current arrangement of Earth's poles and become stuck in that position as rock hardens. This alignment switches each time Earth's pole shifts, resulting in a magnetic reversal pattern. This provides evidence for seafloor spreading and plate tectonics. The location of the earthquakes and volcanoes also provide evidence for plate tectonics. Each active volcano are found near plate boundaries, and most earthquakes take place near or on these boundaries as well. Knowledge about plate tectonics allows scientists to identify areas at risk for earthquakes and volcanic eruptions. Scientists are also able to locate valuable resources such as minerals and fossil fuels. The theory of plate tectonics has had a great impact on the scientific thought because it has unified many theories of earth science. Plate tectonics help scientists understand fossil distribution, earthquake patterns, volcanic eruptions, and climate changes. Scientists also use plate tectonics to observe how the Earth's surface has changed and continues to change.